Okay, on the honors chemistry worksheet that we had in class yesterday and you had to do for homework, let's look at problem 2. So write the equation for the reaction of iron 3 phosphate with sodium sulfate to make iron 3 sulfate and sodium phosphate. And so what you're looking at here is you're looking at a double replacement reaction, because these are just, iron is going to end up with the sulfate. You see that? Iron 3 sulfate. And the sodium is going to end up being bonded to the phosphate, sodium phosphate. So that's what we've got going on here. So let's look at working this problem. It's had some little twists in it. So the first thing we need to do with all stoichiometry is get our balanced equation. And so we have iron 3 phosphate. So iron phosphate is not P. It ends in ATE. So that's our polyatomic. And we have to remember that's a -3 charge. They tell me iron is in the +3. So when I balance those charges, 3 to 3 is 1 to 1. So this is the correct formula for that. So we're going to react that with some sodium sulfate. Sodium is Na. Sulfate again is my polyatomic, SO4. And that's going to be a +1, -2. So when I cross that, I need 2 sodiums for every 1 sulfate. Okay, when I switch partners, I end up getting iron 3 with sulfate. So don't put subscripts yet, just put the formula symbols. This is 2, this is 3. So I need 2 iron, but I need 3 of these groups. And then that's going to give me sodium phosphate. So sodium's Na, phosphate is PO4. Again, just put the symbols. And then you need 3 of these to 1 of those. So 3. So the next thing we need to do is balance the reaction. So again, when you have your polyatomic groups, remember, keep them as a unit. So you have 1 PO4 group here, you have 1 there. You have 2 sodium, 3 sodium. So I already see there's an issue there. So let's put a 3 here and a 2 there. And now let's check our polyatomics. We have 2 phosphate, so I need 2 phosphate. That gives me 2 phosphate groups, 6 sodium, 6 sodium. I have 2 iron, I have 2 iron. Remember, this 3 only goes with what's in parentheses. It doesn't go over here. I have 2 iron, 2 iron. And then I have 3 sulfate groups, and yeah, I have 3 sulfate groups, so we're balanced. Alright, so that's the first thing you've got to do when you've got any kind of stoichiometry. If you perform this reaction with 25 grams of iron 3 phosphate and excess of sodium sulfate, so you have excess, you have this, you have more than enough. This is in excess. If that one's in excess, you're not going to use it all up. What are you going to use up? This is my limiting reactant. So when they give you that clue, that's really nice, because you didn't have to do any work to determine which reactant was limiting. Once I tell you one reactant is in excess, makes the other one limiting by default. So we have 25 grams of that. 25 grams. And we want to go from 25 grams of that, what, to moles? To what? What are they asking me about? How many grams of iron 3 sulfate? Here's iron 3 sulfate. So I'm going from moles of this to moles of iron 3 sulfate. And then I go to grams. How many grams? That's my flow chart. Grams to moles of A to moles of B the grams of B. So that's what this question 8 is asking us to do. So let's get working on that. So we start with our 25 grams of iron 3 phosphate. And to get to moles, I need the molar mass. How much does 1 mole weigh? Okay, so here we'll do our molecular weight calculations. Molecular weight of iron phosphate. Notice I don't care that there's 2 of them. To get molar mass, it's always just the mass of 1 mole. So I have iron plus phosphorus plus 4 oxygen. So that gives me 55.85 plus 30.97 plus 4 times 16, and that will be 150.82 grams per mole. And that's why I'll put 1 mole on top, because this is the mass of 1 mole. 150.82 grams. That cancels. And now I'm in moles of that. I need to use coefficients. So I'm going from this to that. That is a 1 to 2 mole ratio. So 1 mole of the iron 3 sulfate. Notice iron 3, but its subscript is not a 3, right? Cross it over. But iron 3 sulfate to 2 moles of iron 3 phosphate. And that cancels. And then I just need to get to grams. Why? Because they asked me for how many grams. How many grams? So that's going to be the molar mass of that. It's 399.91 grams of iron 3 sulfate in 1 mole. And let's do our molar weight just to help the grader how to show your work, and this is considered work. Okay, so we have 2 iron, so I have 2 times 55.85 grams. And then I have, got to be careful here, you have 2 iron, you don't have 1 sulfur. You have to distribute this 3. So you actually have 3 sulfur, and 3 times 4, 12 oxygen. So I have 3 sulfurs, and sulfur is 32.07 grams, and then 12 oxygen. And that's going to give me the 399.91 grams per mole. So now let's do our calculation for the math for our dimensional analysis. So 25, remember numbers in the numerator, you multiply, but you divide if there's a number other than 1. So we have 25 divided by 150.82 divided by 2 times 399.91 grams. And that's going to give us 33.14 grams of product. Into 2 sig figs, that's going to give me 33 grams of iron 2 sulfate. So this is our answer for how many grams of iron 3 sulfate will be formed. There's my claim. So that's part A. Now let's look at question B. So question B says, if 18.5 grams of iron 3 sulfate are actually made, what is your percent yield? Remember, actually made is what you're doing experimentally. So this is my actual yield. What is this number? What we calculate through our stoichiometry. This is my theoretical yield. That's what we get in a perfect world. So that's theoretically, we should make that. Actually, we only made 18.5 grams. So the percent yield then is simply our actual. So for part B, here's our claim. So the percent yield, always write your formula, actual over theoretical times 100, and you can do this. You don't have to write the words out. And that's going to give me 18.5 grams over the theoretical 33 grams times 100. And when I do that, I get 56% yield. So my answer is 56% yield of the iron 3 sulfate. That's my answer for that. Okay. Part C, is your answer from problem B reasonable? Explain. We got just a little over of half of it, so we'll look at this more in depth after Christmas, so I'm not really wanting to get into that. But if we look at, if you just consider how you would do the experiment, here you've got your precipitate is at the bottom of the beaker. You have sodium phosphate that you've made along with the solid, plus you had this in excess, so these two solutes are still dissolved in the water, so the solution part of this contained both of these solutes, but the solid is going to go to the bottom of the beaker. And remember, we consumed all of the iron 3 phosphate. So if we go back to our balanced equation, and let me get rid of that so it's less confusing. This was limiting, so that's a solid, but you used it all up. So, and this is, if you go to your solubility rules, all sodium salts are soluble. This is a solid, and this is aqueous. So there we go. But anyway, if we're going to look at experimentation, if we were doing a gravimetric analysis, it just means we are going to separate a solid from a solution, and you do that through gravity filtration. So you have a funnel, you fitted it with a filter paper, and you pour the contents of your beaker in through this, slowly let the liquid drip down or the solution drip through, and then the solid collects on the filter paper. And then to transfer it, it's going to take 3 washes, because you've poured stuff that had solid at the bottom, and you've seen that just because you pour it through here doesn't mean all the solid got transferred. So it'll take washes, swirl it around, pour it in, do that 3 times. You may need to use rubber policeman to really get the solid particles out of there and washed onto the filter paper. But I'll show you that technique when we come back from the break. Then once you have that, you still could have some of these solute particles adhered to your solid precipitate. So then you wash again 3 more times with distilled water. And that's just to ensure you've rinsed your solid really well with distilled water, and the only thing you have there. And then you have to let it dry completely and then weigh it. And that's how you would get the mass that you actually obtain. So there's a lot of ways to lose some of your solids you made in this kind of experimentation, especially at the honors chem level, because it's the first time you've done anything like that. All right, so we're not going to spend too much time on part C. Part D is if we now do this reaction with 15 grams of sodium sulfate and we only get 65% yield, how many grams of sodium phosphate will we make? Well, in this one, we're going to redo it with 15 grams of sodium sulfate. So we're going to assume this is our limiting, because they didn't give me an amount for the other one. 15 grams of sodium sulfate, and we only get 65% yield, which is still higher than the other one. So let's see how we're going to work on that one. So this is part D. All right, so part D, we have 15 grams. Here's going to be my claim. We have 15 grams of sodium sulfate. And we need the molar mass, which is, just for quickness sake, I'm just going to go on and give it to you. Sodium sulfate, you would have to show me your calculation for it. 142.05 grams of sodium sulfate. So, again, if we look at our chemical reaction, this is our chemical reaction. This time they gave me that. That's limiting. So I'm going from this, and they don't want me to go to iron 3 sulfate. This time they're saying I'm going to sodium phosphate. So this conversion is going to be grams of this to moles of that to moles of this product to grams of that product. So 15 grams to moles, I've done it. And then I've got to relate moles of this to moles of that. So that's 2 over 3. So that's 2 over 3. And that's 2 moles of sodium phosphate to 3 moles of sodium sulfate. We've gotten rid of that. And now I just need to go from moles of sodium phosphate to grams. So grams of sodium phosphate to 1 mole of sodium phosphate. And the molar mass for that is 163.94. And when I do that calculation, I end up getting 11.54. So I get 11.54 grams of sodium phosphate. Now that's theoretical, and your theoretical is always 100% yield. Your theoretical is always 100%. So if we look at that, we have, that's my 100%, but we didn't get that. So let's set it up for through our formula. We know that the percent yield that we get, which we know is not 100, is always equal to the actual over the theoretical. Well, the theoretical doesn't ever change, right? If it's 100%, I get this. So I want to know what is my percent yield. They told me it was 65.0, and that has to equal what I'm looking for. So I'm looking for the actual yield that I would get if it wasn't 100%, if it's 65, and that's over my theoretical, which is 11.54 grams times 100. So all you do is they gave you, you're looking for the actual yield. How much of this will you make if you're only 65%? So it's just giving you the same formula. You just, now you don't know the actual yield, but you do know the percent yield. So solving this, you're going to get, divide by 100, you get 0.650. I divided both sides by 100. And then I'm going to multiply and then we'll multiply both sides by 11.54 grams. They cancel here. And so I just have to take 65% of that. And when I do that, I get 7.50. So that's my claim, 7.50 grams of the sodium phosphate. That's how many I'll actually make. If I was going to do it in the lab, I would only make that much. Theoretically, I should be able to make 11.54 grams. And that's based off of what we did earlier. Here, 11.54. If I have 15 grams of sodium sulfate, I'm going to make 11.54. If it's 100% yield, they're telling me it's not 100% yield, so it's only 65%. So how much will I actually make? Well, 65 actually over the theoretical times 100, solve it, and that tells me I'm only going to make 65% of basically that 11.54 grams. So you can think of it as just a percentage. I'm going to make 65% of that.